Welcome back to Engineers Workshop. So we're going to shoot part 4 and the conclusion of the Spitfire axle adapters. Project's been going on far too long. I've been interrupted by a number of things, but I've got about 1 million things stacked up ready to go, and these two little parts have just been a lot of steps in these things. So today we've got 2 final operations, 2 sets of counterbores. What could be simpler? Well, we've got a simple one and we've got a not so simple one. In fact, the second, the broken out counterbore, which is at a non-standard angle. I'm going to challenge people that don't have a rotary head machine. It would be difficult to do this operation, but it's going to be even simpler with K&T, and simpler yet with K&T rotary head machine using a rotary table in conjunction to orient each counterbore parallel to the X travel. So let's get over to the machine and crank these parts out. For the counterbores on these 4 holes, it's a 0.875 diameter by 1/8 inch deep, and that's very straightforward. The offset for that with a 1/2 inch cutter is 0.1875. So I'm going to change my head RPM to 1 RPM. I'm going to start the cutter, come down until I just touch, and then dial in an additional 125 thousandths depth of cut. Bring the knee up to get the initial contact. I can see I'm just touching the surface. Okay, so we'll dial in 125 thousandths depth of cut. And we'll double check that before we repeat. A couple more thousandths. Since that's also a clearance diameter, I'm going to let that one go and we'll move on and do the others. We had to put a chamfer on these holes here that receive the studs, because if you look closely at the stud, there's actually a chamfer on that leading edge, and that head would have sat a little bit proud of the surface. So this will let the head sit below the level of that shallow counterbore when we press it in. For the final machining operation, we're going to be looking at the back side, and we have to make 3/8 deep broken out counterbores around this set of holes. Now we could do this on the rotary head, but dimensionally it would get nasty. and there would be a lot of opportunities for error, because what we would have to have is we would have to have coordinates of a starting point, and we would have to run it at an angle. We would be doing that for both of these straight segments, and then we would still have to walk 180 degrees to blend that in. There's a much easier way if we use a rotary table. So we're going to put a little bit of a twist on things. With the rotary table, we can orient the part on its original fixture at the axis of rotation of the rotary table. That means that each of these holes is 1.619 out from that center. And now that hole, the straight milled areas are parallel to the X travel. So all we have to do is offset the head with a 1/2 inch cutter. We offset the head 3/16. We walk in until we hit that 1.619 dimension, actually probably 0 on that, swing a 180 with the head, and then X travel back out. Then on the rotary table, rotate 71.75 degrees, which orients this hole horizontally. Duplicate that operation. So we've got our two oddball dimensions, 71.75 and 108.25. But once we set up for this, I'll bet you I'm going to have both of these parts done in about 10 or 15 minutes. So let's put the rotary table, the giant rotary table, on the mill and set up for this operation. The rotary table I ended up getting was an 18-inch Troyke that weighs about 300 pounds. So needless to say, to handle it, I need to use the overhead crane. And that all-weather enclosure I made for my machine got in the way of me putting it on the table. So once I got it up there, I had to get it positioned over quite a bit to the left side of the table so that I would still have room for a vise on the right. And it worked out pretty well. Everything overhangs, of course, but it's nice and solid, and it'll do the job that I have for it. It's kind of funny. I watched an episode of Winky's Workshop where he, disassembled a rotary table and just tossing those pieces around with his hand. But to disassemble mine, I had to use the overhead crane to even lift the table off of it. We actually don't even have to really indicate this fixture in, because we have a 3/4 inch gauge pin that will locate us on that center hole, which is exactly 3/4 of an inch. Now, we don't want to move the X and Y on the table. We simply want to move the fixture until that gauge enters that hole, because the table is already zeroed. So we'll use one clamp dog to hold the aluminum down. We will place the first part registered in the center, and we'll come across 1.619, and we'll locate that hole with a 7/16 drill bit, which is what we used originally to drill the hole. Got to drop my knee. So there's an accurate location of the first hole. Okay, that's quite a setup, but that will hold it in place. Now we're going to swap out the drill for a 1/2 inch carbide end mill. Now our offset for a 1/2 inch cutter is 0.1875. And we have to orient the offset with the cutter back at, I guess this will be 0 degrees. So at this point, all we have to do is take the table off axis, come down until we touch, and then we'll establish our depth. Table is locked. We'll come down until we touch. Gonna put a little resistance on the quill. Now we come down 0.375. 100, 200, 300, 75. That's pretty deep. All right, this is a pretty hefty cut. It's full width and 3/8 of an inch deep, but I've got the table pretty slow at 1 inch a minute. That's primarily so that I can watch that DRO and not overshoot the 0 point where the cutter is on axis with that hole. I've also got the head RPM at about 1 RPM, so that's nice and slow. And I'm going to have to rotate the head 180 degrees after we zero it out, and then we travel the table back out. So as long as I move the table in the right direction, I won't ruin the parts. Well, that was unexpected. Well, that's disappointing. So I marred the outside of this part, and I actually moved the whole setup, so I'm going to have to clamp this better, obviously, to prevent rotation. Luckily I didn't break another cutter. Now we walk a half circle. And now we exit. Okay, now we just unclamp the table and do that 7 more times without screwing up. So that means we are coming to a new angle of 118.25. Also have to bring the head back around to the opposite offset. Now I'm going to have to figure out how to do 0.25 of a degree. On my hand wheel, I've got 30 graduations per degree, so 1/4 of a degree is 7.5. That would have been a full degree. That's 1/4 of a degree from the last point. I've got contacts, so I'm going to have to move it some more. Okay, the objective on this one is to do the entire part without screwing up. For our final operation, I'm going to put one of these studs in. And it's definitely below the surface. And there's the projection. That'll do what he needs it to do. Well, hope you'd enjoyed that 4-part series on making these axle adapters, these spacers. And we can move on to other projects now, warts and all. We got a good one and we got a visually challenged one here. This is not a working surface on the OD. Wish I didn't screw it up for him. We'll see if he wants me to take a cleanup cut and make this one undersized until those disappear, or just leave it alone and move on. So thanks again for watching. For all the new subscribers, please hit that bell button so that you get notifications for new videos, and share the content. It'll help grow the channel. Thanks again. Stay safe.